Okay. Let me grab my Okay. Let's start. So my plan is to just go over the basic idea of discounting and the idea of the different kinds of costs, average cost and life cycle cost and LCOE. Okay. Um, and after that, I think I'll probably go for about 30, 40 minutes and then we can get into specific questions you might have. Okay. All right. So first is discounting. Okay. Okay. Sorry. So the basic idea of discounting is that simply put, essentially it means that there is a time value of money. Right? You just do not add up different streams of money or equal streams of money that flow at different points of time are not worth the same. Okay, you just and so essentially it's capturing the idea that there is a time aspect to money, right? A dollar today and a dollar tomorrow are not the same, right? And the basic way to compute it is essentially the present value. The meaning of the term present value means what is the discounted value at the present of a future value of money, right? So if there is a future value, its present value is 1 plus r raised to the power of n, where the future value is given to you after n time periods, and the time and the money is worth, or the rate of interest is r, right? So if you get fv given to you n years from now, and if the rate of discount is given to you, okay, you will in our so the rate of discount is simply for our purposes is the rate of interest, and if you want to think of it as the rate of interest in a bank or rate of interest if you raise money from somewhere else, anybody that loans you money, they are loaning you money at r%, or equivalently you can loan that money to others at r%, right? So there is a rate of interest. So that's the value. Now the concept is next concept is annuity. Annuity just means that there is an equal annual flow of money. It could be receipts. So if you're in the case of electricity plants, if you're producing electricity and selling electricity, you get money from selling the electricity, right? That is the receipt would be the revenue you get from selling the electricity. If you're incurring a cost, if you're buying fuel, there is an annual cost of fuel. Annuity just means there is an equal annual flow of payments, and there is a convenient formula. So the same thing. If you spend u dollars n years from now, its present value is 1 plus r over n. If you are given u dollars n years from now, its value is again the same thing, right? So if we call it a net present, if you call it the present cost, if u is a cost, you call it the present benefit if u is a benefit. That's all, right? It applies costs and benefits, we treat the same. What matters is the point at which it is incurred. Okay. So the present, so if you have a stream of money, which is so let's say you receive, so this is benefits, or in general, let's say this is you let's say talk of expenditures, uh, you run a power plant for 1 year, right? You buy fuel, and for simplicity, let's assume all the cost is incurred at the end of the year, right? You spend u dollars this year, its present value is u by 1 plus r. The next year you run the power plant, you incur a cost u. Fuel cost has not changed. In our example, fuel cost is not changing, it's simply fixed. Then its present value is u over 1 plus r squared. You add all of this up, It's U over 1 plus R over N. Okay? The sum of this is nothing but this expression. Okay? It's a straightforward derivation of the geometric series. How do you sum it? I'm not going to ask you to derive it. So it's up to you if you want to memorize it. If you want, you can write it down in your units and calculator sheet and come bring it to the exam. I don't care. Okay. All right. So this applies whether you get money or you spend. This is a general expression. U is just a placeholder for a uniform stream of money. It could be money you spend or money you receive. So the electricity problem now. Oh, and before that, so those are the two concepts: discounting and annuity, right? Net present value is nothing but the benefit minus present cost. Total present benefit minus total present cost. Some of you, when you came to the office hours, I would have said it as net present benefit minus net present cost. It's the same. I'm using the terms loosely. It just means the total is more accurate. Net means it's benefits minus cost, so don't get confused because we're calling the net present value. So basically it is discounted total benefits minus discounted total costs, right? That is, then if you have a uniform stream of benefit, B, instead of B, I'm going to replace with the letter U. If B is the benefit every year, what is the benefit in the electricity problem case?
Rate of electricity?
Not the rate, the sales of electricity. The money you get from selling the electricity, right? That would be the revenues you get from selling. Then that would be B over R into 1 plus R raised to the power of N minus 1 by 1 plus R raised to the power of N, right? The cost, same thing. If B is the annual cost, right, and then C is B is the annual benefit and C is the annual cost. It's the same thing. That's it, right? So benefits minus costs. That's net present value. Clear? Okay. Just now, what I mean by cost, there are two types of cost. There is fixed and operating. Fixed just means it is not varying with how much you use the equipment. So you buy an equipment, like you buy a car, for example, it's the cost of the car. It is not the cost of gasoline, right? The cost of gasoline is going to depend on what? The amount you incur in the form of gasoline cost is going to depend on what? How much you drive, exactly. Right? In the electricity problem, it depends on what? How much electricity you produce, right? Which then will dictate how much energy you need to buy to produce the electricity. You're buying gas, you're converting it to electricity, right? It's directly proportional to how much electricity you produce, right? So that's the operating part. It's a function of how much electricity you produce, which is a function of how well you use your equipment. This is fixed is just what it costs to build a power plant, what it costs to buy a car, what it costs to build a home. This is the cost of running a home, buying electricity, buying clothing, whatever. So that's the difference between a fixed and an operating cost. Okay, you need to get this straight. Fixed is measured in terms of how big your equipment is, and that is measured in megawatts for a power plant. How do you measure how big a car is? For instance, horsepower. How powerful the car is, how big the car is, right? So the price you pay depends on whether you buy a small car or a big car. The cost of gasoline depends on how much you drive it, right? That's the difference between a fixed cost and operating cost. You can also think of this as a variable cost. Doesn't matter. I mean, they're the same. I mean, there are small differences, but for our purposes, they are the same. Okay. You also need to understand. I think it's high time that you guys understand the difference between power and energy. It's not acceptable if you make mistakes this, and there won't be partial credit if you get this fundamental thing wrong any longer. We are far too much into the class to understand the difference between power and energy, right? What is the difference between power and energy?
Power is per time.
Exactly. Power is energy per unit time. It's a rate of consumption or production of energy. That is power. And that is measured in megawatts because watts is joules per second. Energy is measured in joules or other kinds of equivalent units like BTU is a unit of energy. It measures the amount of heat energy. You can convert it or megawatt hours or kilowatt hours, right? Right? So if you make fixed cost, you're clearly told the power plant is 1000 megawatts, right? And so you'll compute the total fixed cost based just on how many megawatts the power plant is and what is the cost per megawatt or kilowatt. Okay? Energy doesn't come into the picture, efficiency doesn't come into the picture. Efficiency comes into the picture only for this purpose, to compute what is your operating cost, how much gas you're buying, which depends on how much electricity you're producing, and the efficiency. Right? Efficiency, I'll reiterate, is nothing but energy out by energy in. You can also think of it as power out by power in. Doesn't matter, the same thing, right? Because time and time gets cancelled. Okay? So you're given 1000 megawatts, you are producing all the time, 24/7, 365. You'll compute how much electricity you are producing in a year, right? That would be in the units of megawatt hours per year. From that, you will use the efficiency, that is E out. E in is E out by efficiency, right? That would give you E in. That would also be in megawatt hours per year. But the price of gas is given in units of dollars per million BTU. So convert that to million BTU to determine how much gas in BTU you are buying and what is the cost of that gas in BTU you are buying. Okay? So that would give you your annual operating cost, right? Which is the fuel cost. So that's the TLC. So TLCC is just another term for total present cost or the discounted present value of cost. This is a different term for it. In the concept, in the context of energy, we call it as total life cycle cost of the power plant or something like that. Or it's a general term. It just means total cost over the life of the equipment. Okay, that's all it means. Anything else? Before I go to levelized cost of energy, so discounting, annuity, NPV. Any questions? Feel free to stop me. Any questions so far? Yes.
So if we're calculating TLCC, do we have to consider the interest rate at all over time?
Absolutely, it's a discounted term. So TLCC is, as said, it is total present cost. When the term present comes, it always means discounting. If the term present is not there, then only you don't discount. Okay. So let me now come to simple average cost. So simple payback, simple average means there is no discounting. You simply take the annual cost and multiply it by however long the life is. Okay? And it's an average. So there is something in the denominator always. Right? If it's the simple average cost of electricity, what will be in the denominator? Now, simple average cost of electricity. How would it be? Time?
Kilowatt hours?
Exactly. You're producing electricity over 30 years. How much electricity you're producing in 30 years will be the denominator. It's the average cost. What is the cost per unit of electricity over the life on average without discounting? Okay. So it's the total cost without discounting of the cost of the power plant. So It's also like a life cycle, but just that it is not discounted. There is no discounting. It's simple. You don't worry about it. It is just for just to get you to think about the difference between these two. I have that. Okay.
So it's just like the fixed cost plus the operating cost before you put the operating cost into present value.
There is no present value.
Yeah, before. So it's just the operating cost and the fixed cost.
Yes.
Okay.
It's the undiscounted total operating cost. Okay. That's TLC. That's the simple average cost. Okay. What is next is a levelized cost of energy. Okay. This is a slightly more difficult, difficult concept. I will do it in more detail. So, what it is essentially, I think I spelled it out very clearly in email I sent it. It is essentially the minimum cost at which you should sell the electricity that you're producing so that you just break even, right? It's the point at which the total discounted benefits from selling electricity just equal the total life cycle cost of the power plant, right? So in the part A or part B, you already computed TLCC. You're trying to equate this to the total present benefits or the net present benefits and trying to find out what is the price of electricity that makes these two terms exactly equal, okay? So you're equating TLCC is equal to this term. Annual, so this B essentially is annual benefits, like an annuity, annual benefits, right? It's like the U term, P over R into 1 plus R raised to the power of N minus 1 by 1 plus R raised to the power of N. So for this problem, you assume, yes?
That's a B over R.
B over R.
Oh, okay.
Yeah. Let P in dollars per kilowatt hour. If you want, you can do in megawatt hours. Doesn't matter. You will appropriately adjust the units. Be that price, which is, or let that be the LCOE, the levelized cost of energy. We want to find out what this P is. That's what we're trying to do. So, can you write an expression for B in terms of P, right? B is equal to what? In terms of P. How will you get B in terms of P? Yes?
Would it be like P times number of kilowatt hours?
Exactly, right? P times annual kilowatt hours produced, annual electricity produced. Very good. Right? It's a 1,000 megawatt power plant. You know how to compute how much electricity you're producing in a year. Okay? That's it. You take this number and put it here. And then you know this, you know this, you know this, you can solve for P. That is the levelized cost of energy. Okay? Think of what would happen if P were a larger number. Let's say you find out P has to be 5 cents a kilowatt hour. That is the price at which the two are equal. What if P is 6 cents? What does it mean? If the actual price at which you sell electricity, somebody is willing to buy it from you at 6 cents, but your levelized cost of energy is only 5 cents. What does it mean? What is that? You make net profits, right? If you're producing at 5 cents, but the market is willing to buy from you only at 4 cents, that means you're making. Yes, right? That's all. So the saying, what is the minimum price? That's why it's called a minimum price. If the price is above, you will make a profit. Yes.
If I do it like another way and do total levelized or total life cycle cost and divide that by number of kilowatt hours to get a rate, would I just have to discount that rate afterwards and get the answer?
That wouldn't work like that. So because if you just discount it by what rate? Because this is the expression. If you're dividing just by the rate, you're missing this whole term.
But if I get like a dollars or cents per kilowatt hour just by dividing like life cycle cost over total energy, that would get me like total
That's,
annual payments, right? And then can't I just like discount that?
That is not your total by what? By what you're saying? By the total?
Yeah, like divide
By
life cycle cost, or life cycle cost divided by number of kilowatt hours.
So that would be this, right? So essentially you're taking this term and you're dividing it by the TLCC. That's what you're saying. You take this, so you're saying divide this term by the TLCC. What remains on the right hand side is this term and this term. I don't know what you call that. Right? I don't know how would you interpret that. I mean, you would get the answer if you can take this along, but I don't have an intuition for it, right? So that is the levelized cost of energy. So what you will find is this in this problem. A check is the net present value of coal, and then the next part is simple. You're given the price. You're given the price is 7 cents a kilowatt hour. So what you do and asked to find out the NPV. So you just plug in the number 7 cents per kilowatt hour, multiply by this, you get the net total present benefits. Subtract the TLCC, that would give you the NPV of coal, and you'll also get the NPV of gas straight away. So in the next question, you are given this P and you plug it in. Okay? Yeah? Alright. The next part is the final part is a pretty tough one. As I said, I think I told a lot of you that it was a bonus question, which was the last time when I had the exam. It was a bonus question, which was basically you could score more than 100 if you answered it. It doesn't matter. Now I made it as part of the exam, so it doesn't matter. It really doesn't affect because it's a class is curved on a grade. So from your perspective, it doesn't matter. I just chose to make it as a question, but it is intended to be a tough question. It is intended to be a tough question by design. I'll give you some intuition as to how you will go about it. The intuition is this. So you should find out after plugging in that the NPV of coal is greater than the NPV of gas, which means coal is a more profitable investment. So let's say you have two choices, to build a coal plant or a gas plant. Which one would you build? If the NPV of coal is higher, which one would you build? Coal, because it's more profitable. Right? Net present value is an indication of profits. You will build something that's more profitable. Will any of you build something that's less profitable? Simple question. Will you build something that's less profitable? Yeah, it's simple. No need to look at other people's faces. Simple question. No. Okay. Unless you want to lose money. So, right. The point of that question is, so now think of what is a tax doing. It's basically adding a cost to you, right? Now we are freely dumping pollution into the environment, right? Now we are saying that you have to pay for dumping pollution into the environment, right? You put out carbon dioxide, which is coming from the combustion of coal and gas. You now have to pay a certain price on that, which is it's like an additional cost. Every time you produce electricity, you produce carbon dioxide, and every time you produce carbon dioxide, you're going to pay money to the government for pollution, right? So what is it like? No, it depends on how much electricity you're producing. It is based on operation. It's based on the amount of electricity you produce. It's operating cost, because more electricity you produce, more pollution you can generate. If the power plant is sitting idle, think of it like this. You build a power plant and you don't produce electricity. Are you putting out pollution? No. Then will you be paying a pollution tax? No. So it's not a fixed cost. It is an operating cost. So it's just adding an extra term to this calculation. That's all. And comparing coal and gas, who is going to be paying more tax? Coal. Right? So we found out that without pollution, the NPV of coal was greater than the NPV of gas. Now what is the pollution tax doing to the cost of producing electricity from coal? It's raising it, right? It's raising it. And what is it doing to the cost of producing electricity from gas?
Well, there you just raised it up.
Exactly. They are both being raised. Both are paying for pollution. But who is increasing? Whose cost is going up more? Coal, because it's more polluting. So at some point, the cost of so as the tax increases, the burden on coal increases, and at some point, the NPV of coal will just equal the NPV of gas, right? And you're asked to solve for that. Okay. So you do the same thing. You assume that it is, let's say it is T dollars per ton of carbon dioxide. You're trying to solve for that T dollars per ton CO2 times amount of pollution. So look at the units. Let me call Z as the pollution that comes out from 1 ton of carbon dioxide. 1. So Z is the tons of carbon dioxide coming out from 1 kilowatt hour of electricity. What are the units of this? So T is in dollars per ton of carbon dioxide multiplied by Z, 1 ton of carbon dioxide per kilowatt hour. It's the pollution intensity. Are you given that in the problem? Are you given Z? What is it? What is Z for coal? It's in the problem. What is Z for coal? 0.95. Very good. And what is Z for gas? But units, be careful with the units. What are the units of 0.95? Kilograms of? Per kilowatt hour. So here I have tons, so you should do the appropriate adjustment. Okay? Or you can do one thing, you can solve for the whole question in tons per kilograms of carbon dioxide. Then you can just use the number and you will give me the answer in kilograms of carbon, tons of the cost in terms of dollar per ton of carbon dioxide, right? So what is the units of this? T times Z. What are the units of T times Z? What are the units of T times Z?
Dollars per kilowatt hour.
Exactly. Okay. What is this like? It's like a cost. I'm paying this much dollars per kilowatt hour. So what is my total cost in the given year? Just based on that units, what will you multiply it with to get the dollars per year? I have dollars per kilowatt hour. That's the burden that's the tax cost of electricity. What is my annual taxes? What is that?
Kilowatts.
Absolutely, that's it. Multiply this by kilowatt hours per year. Now, what would you get? If I multiply these two, what is my answer in dollars per year? So that is then like B, like C. Like that much dollars per year is going out each year for the next 30 years, right? So you can find out what is the present value of that alone, and you will add that to the NPV of coal. So this is the tax cost for coal, and you will add a similar expression to the tax cost of gas, and you will equate the two and solve for T. Okay?
Like the whole term of all the costs.
So all the cost, you don't have to, you already computed this, right? You already know
So
this.
just add that.
Just add that, add this. These two are just numbers, and both of these expressions are expressions in T. So you'll get some number. Let's say it's like 1.5. Just I'm throwing out numbers. 1.5 plus T times 2.3 is equal to 2 plus 1.5 times T. Something like this. Can you solve for T? Yes, that's what we're trying to do. You know everything except T. Alright? So that's the levelized cost of energy. So now you should be able to do the problem. Okay? So I've covered levelized cost of energy. So those are the things I had in mind. Now I can answer other questions if you want.
For the NPV,
Yeah.
the total present cost,
Yeah.
that's just fixed cost plus operating cost.
It's everything. Which one? Net present cost, right? Total
Yeah,
present
yeah,
cost. It's all costs, fixed plus operating. Absolutely. Yes. And it's always discounted when you're talking of net present value. Whenever the term present comes, immediately think discounting. Okay? Because that's the only real actual way to treat costs over long periods of time. For very short periods of time, it doesn't matter. But for anything beyond, so anything beyond a very short time frame and anything that involves a huge expenditure, you have to think in discounting terms because that's how the world works, right? No, when you go and try to buy a car and raise a loan, nobody's going to give you a loan without interest, right? Why do you pay interest? Why are you paying interest? Why is the lender asking you to? Why are people not lending without interest? Can you raise money without interest? Will anybody lend you money without interest except probably your parents? Right? Why is that? Why do people ask for interest when they lend you money?
So the lender has something to gain.
Exactly. Right? Instead of lending to you, if you did not pay interest, he could do something else with the money, and somebody else is willing to borrow money at a rate of interest. Right? So then they would rather lend at a certain rate of interest, and the rate of interest is determined by how much people demand money and how much people are willing to borrow. Right? There is a market for money, just like there is a market for laptops, there is a market for cars, there is a market for money. It's called money market, where people buy and sell, exchange money, right? And that's how the rate of interest is determined. Right? If there is a lot of money lying in the bank and nobody wants to borrow it, what's going to happen to the rate of interest? Very good. If there is a little money and everybody wants to borrow, it will bid up, right? It's like a bid. You go and say, okay, I have money. Who is wanting to borrow? If there are a lot of people willing to borrow, they will bid. Okay, I'll pay you 1%. I'll pay you 2%, right? But the price will be determined by the demand for that, right? If there is more money and less demand, the rate of interest. What happens in a recession, right? If you've heard of the term recession, is essentially that there is not much economic activity, right? We are suddenly very bleak about our future. We think, okay, the world is going down the drain and there's not going to be much demand, so people will stop investing, right? What if I make all this investment and produce and tomorrow there is nobody to buy anything? That's the idea of a recession, that people are very pessimistic about the future. So interest rates are low during recession. And during a boom time, everybody's optimistic about the future. Everybody thinks, okay, I invest and tomorrow there's going to be demand, I can make money for a profit, and so everybody gets into economic activity, then demand goes up, rate of interest goes up. So it's a reflection of basically a lot of things, but basically it's that there is an opportunity cost, right? Instead of, and even from an individual perspective, you use a rate of interest because you have alternative things you can do with it, right? That's why you use a rate of interest to compare things you can do. You may have cash in hand, but still the right way. So you may say, okay, when I go to buy a car, a car is costing $20,000. I don't want to take a loan. I have $20,000 sitting with me. But still, you should think that $20,000, you always have the option of taking a loan. Right? If that $20,000 you have to buy a car, you could put into something else that would become $100,000 in 2 years from now. Whereas the bank is lending you $20,000 at 1% rate of interest, what will you do? Will you take a loan or will you put your money down? All of it. You take a loan because you would rather save the $20,000 and put it into a smart investment that is going to double, and take the money $20,000 from the bank and pay them back, because your investment is actually giving you greater returns than the rate of interest the bank is demanding. Right? So there is always an opportunity cost. You could be doing something else with the money, right? And that's the whole idea this is capturing. When the rate of interest is high, there's a lot of things you can do with the money. So there are people demanding money. When the rate of interest is low, there's too much money lying around. People don't have much demand for it, so interest rates are low. Okay? But this is generally, I'm giving an explanation for what the intuition for interest rates is. But That's why I'm getting you to think in terms of um, uh, discounting terms. Okay. Now, getting into the reading, what does the article, the 2-page article, say about discount? So even before reading the term discounting itself, what does it suggest to you? Is it a good thing? Is it a bad thing? Is it an ethical thing? Is it an immoral thing? Is it a rational thing? Or what it might be, or why under what situation it's problematic, when it is good? What do you think? What are some problems with? I seem to sort of give a very convincing answer why you should discount, and you all seem to buy it. You are nodding your heads. But what might be some problem with discounting? Yes.
I feel like one limitation might be like it assumes that all the spare money you have, like you invest it. But if you just if you don't do anything with it, then it doesn't accumulate interest.
Okay. So you seem to be making a case for discounting.
Yeah.
Okay. What is the problem with discounting, you think?
It makes an investment seem like it's worth less than it actually is.
Which types of investments? Yeah, that's exactly the point I want you to make. But which types of investments look bad under discounting? What types of investments? All investments look bad. Anything that accrues in the future looks bad. That's the idea of discounting, right? You're discounting what happens in the future to the present. So when might it be problematic? Yes.
Could it have something to do with like externalities? Like if you invest in green energy, you might have cleaner air or something like that, but that might not necessarily at a discounting rate save you much money, but it does help.
So that is an important point, but I need you to develop that point further. The whole thing about discounting is the time aspect. So bring in the time aspect. In everything you said, the time aspect is missing. The context is okay, but how does time figure into it? Time. The benefits have to be over delayed. They have to be delayed out, right? So if the cost is today and the benefits are far in the future, it doesn't look worthwhile, especially for investments which give environmental benefits in the future. Right? So all right. What else? Any other question? That's all I had in mind. Yes.
The final units of NPV should be
Dollars.
per year. Just
It's
dollars.
dollars.
Just
It's the
dollars.
life cycle, right? It's the over the life. It's always dollars. That's another check that you are. Yes. Viola?
It's related to the interest rate in the first question, the third point.
Okay.
Is the
First question, third point. Yes.
Yeah,
Okay.
like
Yes,
is the investment should be financed or done with like own money?
Doesn't matter. That's what I'm saying. That's the example I gave just now. It doesn't matter how you're financing the investment. Is it your own money? Or is it money from your father? Is it your money from your girlfriend? If it's money from your boyfriend, if your money from your grandfather or a bank? Doesn't matter. You could always do something else with the money. Right? It doesn't. The nature of financing is not important. It's irrelevant to the calculation of this. It only depends on what is the opportunity value of money. Even if I don't finance it, I can use that money. I said exactly the same thing. Don't put the money into buying the car. Invest in something. If that is going to give you greater return, that's a better investment than putting all of your money into it. There are other very good reasons why you shouldn't put all your money into investment. We can talk about it offline, but I won't ask you questions on that. Again, I'm always happy to chat about these things. I see that all of you come only when the homework is due. That's the sad part. I mean, all my doors are always. I've never turned away anybody from talking about anything you would like to talk about. So, I'm happy to share, but these are way beyond the scope of the class. I already assessed these things. They're going at a fast pace. Yes.
Could you elaborate on private discounting?
What is that?
On private discounting.
Okay, so private discounting is what we have been mainly, again, the main difference, we didn't touch upon it in the lecture, and it is. I just mentioned that in the context that when you do cost benefit analysis, so net present value calculation is what? It's essentially you're doing benefits, your costs, you're comparing them, right? It's like a benefits and cost analysis. That's exactly what it is, except that the term benefit cost analysis is reserved for certain kinds of applications. When governments do it to decide on a public policy project as to whether should we build solar power plants, whether should, as a society, should we finance solar power plants, as a society, should we invest in climate change. When you do net present value calculation, it's called as benefit cost analysis. But the principle is the same. You calculate benefits, you calculate costs, and you discount it, but you're doing it from the society's perspective, right? The main difference in the society's perspective are two things. One, externalities. You think about the cost of pollution. So think of yourself, if you're an individual person, right? Do you care about, you guys are motivated people, well-meaning, and you guys care about the environment, so you guys are not a very good representative example. If I asked you, do you factor in the cost of the environment, you might. But think of the average person, right? Or even yourself, when you're making huge sums of investment, and essentially you want to care for the environment and you want to take into account the environmental cost, but nobody else is. Everybody is living as though there is no tomorrow, and they are not considering environmental impacts, right? When you do a calculation and you are going to raise money from investors and you say that, okay, give me money so that I can build a solar power plant, right? And you say, okay, the solar power plant gives a lot of environmental benefits, right? Will they finance it? Probably not. They will say, I don't care. I will give you money if you pay me back at 7% rate of interest. It may be that the solar power plant will pay back at 5% rate of interest because it's costlier. It takes a longer time to get back the cost, and because you don't factor in the environmental benefits. If you factored in the environmental benefits, maybe it's a 10% rate of return, but it's not priced. Nobody is benefiting from that, right? So then, essentially, if you went and told an investor, I will pay you back your money at 5% rate because that's what I'm making, but the investor has options that a coal power plant wants his money. He says, I want to build a coal power plant, I'll give it to you at 7. He's going to give the money to the coal guy. He won't give the money to you, because he can get back his money quicker at 7%. Right? So then you are also forced to think about just the cost and the benefits in a narrow term, right? Because the market doesn't allow for it. But as a society, if I'm a public policy maker, I should be thinking about it, right? So then I should be giving incentives to solar power plants and say, okay, you return at 5%, I will give the investor the extra 2%. I will compensate him. So you are doing a benefit cost analysis from a society's perspective. You might well decide it's worth as a society to subsidize solar energy. Right? So you're looking at costs and benefits from a societal standpoint. You might also use a different discount rate. That's the social discounting part. Because if you think about it, the private market, the lenders, they're short term. Right? They're people like us who live for 40, 30, 40, 50, 60 years maybe. And their horizon is 10, 15 years of planning horizon. They don't think about what happens in 100 years' time, right? So all the investments we make today are short-term investments, right? So the market may be reflecting our impatience, right? Essentially, what is it? It's impatience. We don't live for 100 years, so why would I care about what happens in 100 years, right? So that might skew the interest rate towards being artificially high. These things pay back quickly, but they impose long-term costs in society. So the true rate of return is actually smaller if you really do proper discounting. So that's social discounting. Okay, the main difference is you take into account a much longer term perspective, and it's not from a private perspective; it's from society. We think as a nation, because the nation will be there in 100 years' time. We may not be individually there, so we think of the long term. Anyway, unless we get into private and social discounting in the second half when we talk of economics and policy, you don't have to worry about it until that point. And if I don't touch upon it for any reason, but it's since you asked the question, it's probably worth knowing. It's a very, very difficult, complex topic, highly debated topic, very controversial topic. What interest rate is, or the what a discount rate is, makes or breaks everything. Makes or breaks every calculation about climate change. It's a very, 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 very controversial topic, complex topic. It's still the world's top economists are debating, arguing it. But for our purposes, we are just, I'm just introducing you to, it's finance 1A for you. So don't worry about it. Okay. Yes, any other questions? Yes.
If there's no other questions, could you go into the difference between megawatt and megawatt hours again?
Okay, megawatt, maybe you joined in late, or I don't know, I'm happy to do it one more time. Megawatt measures power. It's the instantaneous flow of energy. Megawatt hours is energy that is produced or consumed over 1 hour, right? It's 1 megawatt. So if you take a light bulb that is 60 watts, we should move away from incandescent bulbs. It's high time. Even as an example, let's take a compact fluorescent lamp. It's 15 watts. You run it for 1 hour, right? You're consuming 15 watt hours, right? If your 15 watt bulb running for 1 hour consumes 15 watt hours of electricity, right? This is energy in electrical form, but it is energy. This is power. So in the power plant example, 1000 megawatts is power. If the power plant runs for 1 year, it is producing 1000 megawatts times 8760 hours per year. That would be 8.76 into 10 power 6 megawatt hours per year. Okay?
So would megawatt be in terms of seconds?
It is megajoules per second, right? Watts is joules per second. Yeah. All right.
Would an investment with a high upfront cost with greater benefits, like if you raise the interest rate,
High upfront cost and what?
It's basically just one.
3. Okay, 1C. Okay.
So I'm saying, would like a higher interest rate make that investment seem worse, since like you can invest your money elsewhere?
Absolutely. A high interest rate means high rate of discount, right? Which means you are discounting what happens in the future at a faster rate. But you can also think of it as like impatience, right? If you're discounting something that happens in the future too much, it means you're impatient to consume now. You can view it as an sort of, think of it as like impatience. It reflects impatience. It reflects the impatience of the market. It reflects the impatience of the lenders, right? What else, guys? Anything else? Okay, if not, I'll be in my office and you can come get me, and happy to